This video is about using GitHub Classroom, a platform we have selected to host the programming practice assignments for CprE 1610. Through GitHub Classroom, you'll be accepting these programming practices, editing your assignments, testing them, submitting them for automated testing, and eventually getting credit for each of these programming practices. And while GitHub Classroom is very cool with a lot of really nifty features that you can use to help make your programming experience a little bit more beneficial, it also has a little bit of extra complexity compared to our prior platform that we used. So I wanted to make sure to make this video to give you some additional insight as to how I use GitHub Classroom, and hopefully you can follow along and follow a fairly similar practice for your own programs. As I mentioned, in the recent past, we were using the Replit platform to host our programs, and you'll still see some evidence of Replit in our learning module videos. Replit is great. It is still valuable if you want to quickly spin up an instance and play around with some code. It doesn't quite work any longer for our academic educational purposes, so we've made this switch to GitHub Classroom. Some things are still the same. The primary start and end point for each of these PP assignments is going to remain in Canvas. Each GitHub Classroom assignment will be directly linked in Canvas, and it'll have a URL that'll look something like what the following has there with classroom.github.com. After you've completed the assignment and your program passes all the tests, GitHub Classroom will generate a unique looking Canvas submission code that'll look something like the following. Let's get started from the Canvas perspective of where we begin with each of our assignments here. Here I have Learning Module 2 open, and you can see beyond the lecture slides and the individual videos, we have the individual links to the PP0201 through 05 for this particular learning module here. You can see the link, classroom.github.com. I actually like to save that link first before going to it. And what I do is I keep a separate little text file that stores all those things like the individual links as well as the solution codes. So here, I've just stored that link. When we get it working, I'll also store the solution code. You can always go back to your GitHub Classroom assignment by going back to Canvas and clicking on that link again. And there's other ways you can navigate to your prior accepted assignments, but having that link handy, all those links handy in one place is a really easy way to kind of navigate through the various GitHub assignments that we will have here. I have that link copied. I'm going to open up a new tab and go to GitHub Classroom. And the first thing it's going to ask you is whether you want to accept the assignment. If you're not yet in our list of net IDs for GitHub Classroom, it'll ask you to pick your net ID. Afterwards, it'll ask you just to accept that assignment. And if you want to work on it, you should click yes, I accept this assignment. This will then say you're ready to go. It's generated what GitHub refers to as a repository for your individual assignment. I actually also like to open this link in a separate tab, and I'll show you in a moment here. Going back to the slides here, here is my view of the general GitHub Classroom flow that I'd like you to follow. It does start with Canvas. So you log into Canvas, you're going to access the next GitHub Classroom assignment via the corresponding link in the learning module page. We just did that. And then you're going to accept the GitHub assignment and view the repository. Next, it's time to actually get started on the assignment. And here I want to take a quick pause and review the different options that are available. I mentioned sort of a 30-second wait here. It does take a little bit, not a full 30 seconds, a little bit of time for it to actually generate the GitHub code spaces for it. You can also edit it directly from the repository page itself. One thing that's really great in terms of a feature is that there's many different ways to edit your code using GitHub. The mechanism I recommend, and it should be sort of your default, is to use the GitHub code spaces. So I'm going to click this link here that says open in GitHub code spaces. We'll talk a little bit more about some of the benefits of your GitHub code space, as well as maybe perhaps some of the limitations of using a GitHub code space. But we're clicking on it. We're going to wait for it to load up here. Work on edit the PP in one of multiple ways. Code spaces, we'll talk about VS Code. You can also do so locally. And then as we're working on our code, it's going to be important for us to actually test our changes in the console tab. Tabbing back to our GitHub code spaces here, we have a listing of the individual files that are part of this assignment. They're all going to have, at the very least, a markdown file, which is our sort of README, our instructions here. I like to be able to see the markdown file in the sort of preview mode in which you're actually seeing the rendered version of it. And I clicked one too many times, so I can actually close out of this one here. And then I also want to be able to see the source file that we are editing. You're going to want to generally have those two tabs open. On the right, and the order doesn't necessarily matter, you have essentially the instructions for that assignment. On the left, you have the source code that you're supposed to be editing for this assignment. I don't want to belabor the point too much. We can actually try to solve this assignment, but you really do need to start here. The program's called circle size. It has us working with floating point values. And if you don't know that yet, that's okay. This is sort of before we get started here. The program is asking you for this programming practice to use the code to calculate the corresponding circumference and the area for that circle. Circumference 2 pi r, area pi r squared. We have variables defined, so a lot of the starting code is already doing a good chunk of this for you, and that's okay. And we can do things like, let's calculate the circumference is equal to 2 times, and we have the pi thing defined for us as it lists as the instruction, times our radius. And then our area, let's list it as 2 times m times pi times radius squared. That would be one way to do it. The rest of the code is actually already in place for you. There are different ways one can build and test this code locally. My suggested approach is we stay within this tab on the bottom called terminal, and the command to build it using the make file that's provided that you don't need to edit is just called make. Build my application for me. That generated a bunch of files you generally don't have to look at, but they're in our file view here. Then we want to test our program. The programs for this class are all going to be called main. Because it's in the current directory, the command to execute that program is going to be /main. Enter a radius value. I don't really have a great idea what would make a good radius. 1.0 might be easiest to test. Circle of radius 1.0 has this circumference and that area. That doesn't seem quite right, but it's kind of close to me. As we're working on the code and as we're in this step, and I'm attempting to show it as something of a feedback cyclical loop here in which we're editing the code, we're testing the code, we're running make and main. We're making sure that the code does something reasonably close to correct that we're happy with here. That is where you're going to spend a decent amount of your time on these programming practices. That's the point of this class. What is new in our GitHub classroom-based approach for this is a couple things. There's going to be a directory called tests, which is mostly just for you to kind of take a look at and observe what is in these tests. There's the names of the tests. Those are basically just the names of the tests and what files they're found. There's then a .in file corresponding to each test. In this case, 1.0 would be the input to one of our tests. And these values would correspond to, in the next file, the .out file, what the outputs would be for that particular test. We can detect if you've made any changes to these test files, and it won't be allowed to pass the automated tests in that case. But if you want to see what tests we're going to be running, they're all located in this files. Going back to our slides here briefly, there's then that next box where it says commit and push / sync with some sort of message associated with it. This is a very Git and GitHub specific thing that is required to use this infrastructure. I would say every time you are making a quote unquote meaningful change to your programs, you should be doing that commit and push. Now, if you were using this Git for your own projects or you're collaborating with others, there's oftentimes a reason to do all sorts of commits separate from doing a synchronization or a push. However, for our purposes, in which we have this GitHub codespace open, and you really are only properly testing your programs once we've pushed your changes to the repository, you're almost always going to want to just do both. So by default, I clicked on this source control tab here on the left. A green button showed up that said commit. We're actually generally going to want to change it to another option that's going to both commit and push / sync. There is a message required. How meaningful you want that message to be is kind of up to you. First attempt. I mean, the message is mostly for just internal consumption at this point. If you want to be able to keep track of what your various changes are, keep them brief, to the point. first attempt at updating area and radius. You don't need to write paragraphs. No one's really going to read them. I'm going to then click this drop-down box and choose commit and push. And it's going to ask me, there are no stage changes to commit. This is some Git specific verbiage that this class is not about becoming experts in Git. You can click yes. You can actually also click always for that option. And it's going to actually then do that staging, committing, and pushing here. And it's actually already done. Let's go back to our slides briefly here. After we've done that commit and push, it doesn't seem like very much has happened. But what actually happens is that code gets pushed back to github.com. It is then running an automated test script that's checking all our inputs, checking all our outputs, and letting you know whether or not you passed all of those tests. Quite often, some or all of those tests are going to fail. We have to review our output for those tests. So this is one of the reasons why I kept this other tab open, which was the repository view of our individual project here. You can actually see this change that was made, this push that happened here. It says first attempt, and it's got some X's. It says failure. It's not failure. It's just not success yet. You can actually click on that red X to see the results. The other place you'll find it is in that Actions tab. So when in doubt, go to the repository listing for your assignment, click on the Actions tab, and then you'll be able to click on First Assignment, and you'll want to actually click on this button as well. It says Run Auto Grading Tests. The automatic grading can fail at different points. If you have a compile error, it'll fail here. You shouldn't be pushing too many changes that have compile errors because you have the ability to test it locally before you do that commit and push, but it can happen. In this case, it did compile, but as it's attempting to run the test, well, we're getting these red X's here. And what will become important for you is to be able to relatively quickly triage these errors as you see them. For me personally, even though in this case there's 1, 2, 3, one of them did pass, 5, 6, 5 out of 6 failed, I'm pretty much going to focus on the first one that failed. They're not necessarily always going to be in ascending order of complexity, but if you don't get the first one working, you won't get the rest working anyway. So as opposed to trying to fix everything at once, because they could be different bugs, that's not the case here, but they could be different bugs in the future, just start with one at a time, try to fix one thing at a time. What it's attempting to show you is, okay, it ran test 01. We can go back and see exactly what test 01 was all about. Here is the diff, the differentiation, the difference between what it expected the output to be and what your output was. A little hard to read. It's not that user-friendly, but the text that is in white is the text that actually matched. Seems pretty good. Circle of radius 1.0 has circumference 6.283, and then when it prints out the area, it gets a value. The red is what yours outputted. The white, there happens to have the value 2 in common. The green is what it was expecting. So one way to read that is it should get a value of 3.142, but instead it's getting a value of 6.283. We don't have to really necessarily fix it on a digit by digit basis, but if you need to, the information is there for you. And if we want to look ahead to the other tests, looks like it's doing something kind of similar. Seems like the value we're generating, 6 point something, is maybe 2x the value it should be generating, 3.1 something. Going back to our slides here, don't despair. Review output and code and keep at it. Post your questions at this point. Hey, I'm stuck. I'm getting this, screenshot of where the result is different than what I'm expecting. Please help. We'll help. That's our job. This one, maybe we can go take a look at it ourselves. I still have my code space open. I tab back to it. We can ignore a lot of those automated messages. There are extensions. It seems like it's pre-configured pretty well already. Looks like the result we were generating is maybe twice what it was supposed to be, and I can actually see that here. Why is that the case? Well, we have something of a logic error here. If we go back to our makefile, the equation for area is pi r squared, not 2 times pi r squared. So my suggested fix is to do that. Now, do I need to build it locally, run it, test it again? You should. I'm not going to, but you should. Every time you make a change, hit make, go to run main, confirm that it's actually working. In this case, it's a pretty quick fix. I think we've fixed the bug. we're going to go back to this tab here. We have to provide another commit message, updated area equation or area math, however you want to say it. And again, commit and push. It's going to do that. It is now pushed back to GitHub. We're then going to go back to our other tab. This is the first attempt still. Under your action tab, it won't take too long. In my experience, not much more than 15 to 20 seconds. For the second attempt to run, you can click it while it's actually running and see the results as they're being generated, or you can just wait for it all to finish. Sometimes it takes more time than others, but now we look at this, it looks pretty promising. Green arrow is good in this class. You can click if you want to see the test passing. Just shows that they all pass. There's no difference between your output and the expected output. Congratulations. What you then need to look at is this next box, which doesn't kind of expand on its own for better or for worse. But it says, success, all tests pass. This would be mine, not yours, your unique submission code for this user ID and this program is this. Please be sure to copy paste this entire code into the Canvas submission for it. And we could do that right now. I have the tab open. It's the corresponding PP assignment for this one, PPO2 circle size. That's what I copy paste in there. The downside of Canvas is it doesn't remember your results. So if you're going to work on one program today and one program later tonight, one program, other program tomorrow, you're going to want to generally submit all your programs for a given assignment at one given time. So this would work. I could click submit. I will get the points for that particular program. But actually, if we go back to our text editor that we were just keeping track of things, that's where I'd put that for now. And then once I've finished PPO2, 01, 02, 03, 04, 05, I would have all 5 of those codes. Then I would go to Canvas and then do my upload. This way, you're not having to go back to GitHub and checking the code over and over and over again. We had success. We copy paste the Canvas code into our local file, have it ready for Canvas submission. You're going to get your credit for that assignment, and you get to move on to the next one. They won't all take just a minute or two like ours just did, but they hopefully won't take too long. I opened up that code space as our example editor, but there are in fact multiple editors available to you for better or for worse. Each assignment is configured to default to edit via that GitHub code space. It's pretty nice. It provides you pretty much everything you need when doing this kind of editing. Gives you view of your files, gives you ability to edit source code with nice kind of syntax highlighting, lets you see the markdown, lets you test things locally. It's pretty much all you need. And so by default, that is what I want you to use. There are some other options when you look at the editing options within GitHub itself. There's github.dev, which is another online IDE, which is nice. What it doesn't provide is everything that's in the bottom half of the screen. There is no terminal available for you there. It is just an editor. You should use CodeSpaces. What I say here is if you have something very quick you want to change, maybe consider using it. Otherwise, you really shouldn't. And you should just use CodeSpaces if it's working for you. You can also directly edit in the web browser in GitHub itself. If you know you just forgot a semicolon, that's the only thing you forgot, and you don't want to open up CodeSpaces again, okay, fine. Edit it right there. If you have some experience with using Git yourself, either via Git command line, Git shells, or the Git desktop sync utility, which is quite nice, and you have your own environment on your own workstation, on your own laptop for doing development, please feel free to do that. That is going to be a more efficient way of working on these assignments. They're all going to be located in one place. Assuming you sync them all to the same top-level directory, you can use your own editing tools that you feel very comfortable with, and then everything else is still going to work the way you hope it would in terms of pushing, committing, getting your code back out. My only caveat with that is that if you don't have that experience, given the nature of the students in this class, starting and stopping at different times, I really can't provide much in the way of like technical support with your local tool installs. If you say my compiler is no longer working or make isn't installed on my system, my advice for you is going to be, well, go back to your code spaces. That's already provided access for you. The other big caveat, and when we experience it, we'll just overcome it, is that via GitHub policy, you're limited to only using 2 of those code spaces, separate ones, at any given time. I think in practice that should be fine, right? You maybe have one code space open for the current assignment, and perhaps to see what you previously did, you had one code space open for the prior assignment. These assignments are related, and so it makes some sense to have two things open kind of side by side. And they will auto-sleep. After roughly 30 minutes of inactivity, the code space will go to sleep, and you can open up another one if you haven't otherwise. The other option is there's a separate website to review all your open code spaces, and the link is provided there. Or you can go in the terminal and just manually stop your code space when you know you're done with it. For this one, it served its purpose well. I can probably stop it. GitHub, code space, stop. It asks you to select which one you want to stop, but it's kind of the default one, so you press enter again. And it doesn't look like much happened, but this code space is now done. If I'm trying to type things in, it's not going to let me type things in anymore. We have effectively stopped our code space. This, I think we've already provided a reasonable overview of it, but you can refer back to this slide afterwards to see the different aspects of your code space window. That's your code tab. That's where you're editing your programs. This is your secondary tab. You really do want to have your README file open, your instructions open while you're working on these programs. I provide lots of hints in those instructions. I'm also very explicit in terms of here is what the output must look like. If you're missing a period at the end, if you have an extra space at the end, it's not going to pass the test. And the information in that README should be sufficiently correct and complete in terms of what your output needs to look like. We have the console tab. I review here the make and the /main commands you're going to run. Make to build your program, /main to run and execute your programs. I also mentioned the tests are available here. You can review those tests. Unfortunately, the way I have it set up, if you edit any of those tests, it's going to flag your assignment as having modified a protected file. So do not commit any changes to any edited tests. It's not going to work correctly, and you may not receive credit for that particular assignment. Then you have the File Explorer, like any other File Explorer, to view the different files in your repository. And then that button that we click to do the source control. Commit and push your changes, or commit and sync your changes, and you will be able to then run your automated testing. And a final note, the point of this course is to help prepare you for future programming courses like Computer Science 2270. The point of this course is not to see how much you can struggle. Some trial and error is intended, some trial and error is okay, as is getting temporarily stuck. That is okay, that's by design. But if after some significant effort on your part, your logic still isn't working, or you're just having syntax or compilation issues, or certainly if that GitHub flow is just not working as you think, or if you're just confused, your responsibility is to reach out. Please post on Discord. We'll be able to take a look at your code. We'll be able to potentially make a quick tweak ourselves to your code, or at least provide some advice as to where we think your code needs to be updated to actually work for you. Post in the appropriate channel. If you're on PPO5, post in the PPO5 channel. You can provide the URL for the repository, the thing we copy pasted into that file. No one else in the class, no other students in the class will be able to see your code, so there's no worry about providing that link. Usually you should feel some responsibility to provide a succinct, quick message, what you're seeing, what you think is going on. And of course, if you have any screenshots of any incorrect tests, when you do that, that can really be helpful. When I look at this screenshot, this is for a different program you'll be working on a little bit later in the semester, where you're trying to determine how many digits are in an input number. And I look at this one and I see, well, it's actually reporting out 10, but the correct number is 9. You have a bug, and that's okay, but you have a very specific bug, which is great because we know how to fix very specific bugs. That's GitHub Classroom. It's a little bit of an experiment as we're trying to use this and hopefully use it effectively for our class. It's got some really cool features like we saw there, but a lot of steps that have to be followed pretty precisely for it to work for you. I wish you all the best of luck with this, and please ask questions. Please reach out for help if you need it, and we're very happy to assist you in your programming journey here. Good luck.